Okay. So here we're just doing some more examples of isosceles triangles. So for this diagram, they haven't given you a whole lot. I always look for a couple of things. I look for triangles where I have 2 out of the 3 angles, or an isosceles triangle where I have 1 angle. Either one of them is enough to get more things. For example, this triangle, I've got 2 out of the 3 angles, right? We've got the 21 and the 35. If I add those together, you get 56. That's angle E. The exterior angle is equal to the sum of the 2 remote interior angles. So this angle, see how it's outside of this triangle? And these are the 2 interior angles that are not right next to it. We call those remote interiors. They're remote because they're far away, interior because they're inside. If I just add those 2 together, I get this angle. Well, if that's 56, because these 2 lines are parallel, this is also 56. I could find this angle, that's 56. Those are vertical angles. And if you subtract 56 from 180, we can find the linear pairs are 124. So each of these angles is 124. And that's as far as you can go with that piece of information. But now, look at the triangle over here on the right, this great big triangle. What kind of a triangle is this triangle? Anyone? It's an isosceles triangle. These are the 2 legs, so this is the base. It's always important to identify which part is the base. Right, Matthew? You okay?
Yeah, I'm just attentively looking at it.
You're falling asleep is what you're doing, but... All right, so if that's the base, then the 2 angles at the ends of the base are going to be equal to each other. So F is 48. Well, now I know 2 of the angles inside of this triangle. So I'll go ahead and add them together and subtract from 180 to find the last one. 48 and 48 is 96. Taken from 180, that leaves 84. So this angle is 84. And you might think that you're stuck there, but you are not. Because what do we know about these 3 angles down here? Yeah, their sum has to be 180. So I'll add 35 and 84. It's 119. From 180, that's 61 degrees for D. Well, now I can find angle C because I know 2 of those 3 angles. So add 56 and 61. It's 117 from 180 is 63 for C. There are 2 ways to find this angle right here. One is to look at these 3 angles. What do these 3 angles add up to? 180. So 56 plus 63 is 119 from 180. Oh, wait a minute, I already did that calculation right over here. It's 61. Why is this angle the same angle as D? Because they're corresponding and the lines are parallel. That would have been the faster way. Then what kind of a triangle is this over here on the left? Isosceles. Here are the two legs. So this is the base. The base angles are the same size. So A is 61. And then to find G, I'll add the two 61s together. It's 122 from 180. And that's 58 for G. Any questions about that? All right. Let's work a couple of perimeter problems. So remember that the perimeter of a triangle is not any special number. It's just the sum of all the sides. It tells me the perimeter is 56, but then it asks me to find angle T. And at first you may be going, what does the perimeter have to do with the measure of that angle? Well, it's not immediately obvious. But how do I find perimeter? Add up all the sides. Which is the only side I don't know then? JD. So if I add 23 and 10, that's 33. Subtracted from 56 is 23. Oh, hey. What kind of a triangle is this then? It's isosceles. But they didn't tell you that it was isosceles. They gave you enough information to figure it out. So these two are the congruent sides, those are the legs, so this side is the base. It's always important to identify which side is the base. Why? Because the two base angles, the angles at the ends of the base, in this case J and T, are congruent to each other. So if angle D is 56, subtract that from 180. That's 124. And then we're going to divide that in half because these two are the same. So 124 divided by 2 is 62. So the measure of angle T is 62 degrees. Excuse me. All right, let's look at this next one. They also tell you the perimeter on this problem. They tell you that angle K is congruent to angle Y. So if those two angles are congruent, which side is the base? RY is not the base. RK is not the base. KY is the base. See how up here when you have the base, the two angles at the end are the two that are congruent? That works backwards also. If these two angles are congruent, then this side is the base. Which means what about the other two sides? They're the legs, which are related to each other how? They're congruent. These two sides are congruent. Now it tells me that the length of KY is 4x plus 12. And the length of KR is 3x minus 5. So the length of YR is also 3x minus 5. So then adding those together, 4x plus 12 plus 3x minus 5 plus 3x minus 5 is equal to the perimeter, 82. Grouping the like terms, that's 10x plus 2 is equal to 82. Subtract 2 and you get 10x is 80. Divide and we get that x is 8. So then YR is 3 times 8 minus 5. It's 24 minus 5 is 19. Okay, any questions about that? Okay, then I have a worksheet for you for your assignment. We will have a quiz on angles of triangles. I'm still playing with it. It's on the schedule for Friday, but if we took it Thursday, then on Friday you'd have more time to do homework in class and have less homework over the weekend. One way or the other. If anyone has a strong opinion about it, you can talk to me about it later.